In this video we will be discussing about the monoclonal and polyclonal antibody. So what they are, and okay, so let me write over here monoclonal okay. So if I would tell you that what is the meaning of the monoclonal, mono means single, okay, and talking about the meaning of the word clonal. What is the meaning of clonal? Clonal means copy, okay, means the single copy. Now here I'm writing like terminology antibodies. Mono means single and clonal means copy. So here I'm writing antibodies. What is the mean by antibodies and what is antibodies? By this word we can say that antibodies are the protein, you can say the special protein. What they are? They are special protein that are present in Y shape in our body. Y shape in our body. What's the function of the antibody? When the foreign particle attack on us, so this antibodies will protect us from the foreign particle. Okay, so a special type of protein that are in Y shape. Let me draw the Y shaped protein over here. Oh, sorry, antibodies over here. For example, at this point here, the variable part of the antibodies contain epitone. What? Here it is a part that contain epitone. What? Epitone. We'll be discussing epitone as well. Like it is a part where epitone is attached and this part is known as binding site. What this is known as? Binding okay. So this is the antibodies and over here it is a Y-shaped antibodies, and at this place, at this area, the variable part of the antibodies contain epitone, means epitone contain. What is epitone? Epitone we'll be discussing that what is epitone. There are the different type of epitone and epitone varies from antigen to antigen. Like here is a cell and here is the antigen of the cell. So epitone of this antigen will be like different epitone. Here another epitone will be attached, here another epitone will be attached. So epitone varies from antigen to antigen. Okay, now we will be discussing polyclonal. So in our body, in our body, both in our body, both poly and mono clonal bodies are present, and like they are extracted like monoclonal antibodies. If we talk about the monoclonal antibodies, so they are extracted, means they are extracted from where? They are extracted from the single special, extracted extracted from, oh sorry, they are extracted from single WBC, and that WBC is also known as hybrid WBC. Okay, means like every like in this condition we'll be making only one what do we say, WBC. Okay, extracted from where? It is extracted from, monoclonal antibodies are extracted from a single antibody. So let us discuss that what are the monoclonal and the polyclonal antibodies. Okay, this is the cell, this is the cell, and here the antigen is like attached. Okay, antigen, what is antigen? Antigen is the foreign particle. Antigen is a foreign particle. And to like kill that particle we are making the antibodies. Mean like antigen is a harmful particle. Okay, what is antigen? It is a foreign particle. So for example here, as we know that every antibody have a special epitone, and that is known as the binding site. So this is the epitone. This, consider epitone 1, consider here epitone 2, and consider here epitone 3. Okay, so every epitone have its binding site, and every epitone is attached to what? I'm sorry for this. Let me make this is the cell. Okay, so every epitone have the binding site. So here is the binding site. Like let me draw it again. Erase it. Let me erase it. Okay, I'm making it again. This is the antigen attached to the cell. This is the epitone. Okay, this is another epitone, and this is the third epitone. So what is epitone? Like every antibody have the binding site. Okay, so that binding sign of the that binding sign of the like antibodies attached to the antigen. So as you can see here, it is attached with the antigen. Okay, this is considered, and that is known as epitome. So consider that this is epitone, this is epitone 1, this is epitone 2, and this is epitone 3. So to every epitone, there at every epitone the like single plasma cell is attached. Why single plasma cell is attached? Because we know that the plasma cell is for making the antibody. So like at here I'm writing PS, plasma cell. Okay, at this epitone 1 the plasma cell is attached. Then for the next epitone there will be another plasma cell. Okay, here another plasma cell is attached. Here at 3 epitone 3 plasma cell is attached. So every epitone there is a different plasma cells. Why? Because plasma cell make the antibodies for the epitone 1. Like for example, here is the plasma cell. So why we have different plasma cell? Why not one? Because when the plasma cell will attach with this epitone, so it will always make the antibodies of the number 1 epitone. For consider that this is plasma cell 1, this is plasma cell 2, and this is plasma cell 3. So for example, the epitone 1 have the plasma cell 1. So now if these two epitone do not have the plasma cell, so who will be making the antibodies of these epitones? So that is why different like so like every of the epitone will have one plasma cell, because we know that plasma cell of the one like only work for the one epitone, and it will make only the antibodies. It will what? It will make the only and plasma cell will always make the antibodies of only the one of epitone. Okay, so for like another epitone we will also be requiring the plasma cell. So that is why here second plasma cell is being attached. Okay, so as you can see here, the second plasma cell is being attached with the second epitome. So now what we have to observe over here, that as you can see, for the different like epitone, different plasma cells are making antibodies. Okay, here you can see, for let me write, for different epitone for the different where I don't know, oh god, yeah, for the different epitone there are different P cells, means the plasma cells. There are different P cells. But what is similar? But the antigen is one. What the antigen is one. Like for the one for the same antigen, there are different plasma cells that are making a different antibodies. So those antibodies will be known as poly. What they will be known as? They will be known as polyclonal antibodies. What they will be known as? Polyclonal antibodies. So that antibodies are known as polyclonal antibodies. I will repeat for you again. Okay, let me raise it. Okay, so for the different epitone, as you can see, there are 3 epitone being attached. For the different epitone, there are different antigen. There are different antibodies. Sorry. For the different epitone, I'll highlight it as well by reading. For the different epitone, okay, for the different epitone, how? Because every antigen will have the binding site, but the binding site will be different, and those binding sites are known as epitone. So for the different epitone, okay, for the different epitone, there will be different plasma cells. What? There will be different plasma cells. There are different plasma cells. Okay, for this epitone we have this plasma cell, for this epitone 2 we have this plasma cell, epitone 2 plasma cell 2, we have this plasma cell of epitone 3. So but what is common over here, but the antigen is only similar. So the antibodies will be making in that condition is known as poly polyclonal antibodies. Polyclonal antibodies. Those antibodies are known as polyclonal antibodies. Okay, I hope you got it. Now we will be looking at the monoclonal antibodies. I hope that is clear. I'm like making you understand in a very clear way. So now we are taking one example. We are taking this epitone. What we are taking? We are taking this epitone. Over here we are taking the example of this epitone. Oh god, I don't know what is happening today. Sorry for the distraction. We are taking over here. Okay, we are taking the one epitone here. So for example, here, like, then what the epitone will do, like when the epitone will start dividing mitotically, what mitosis will be occur, then mitosis will be occur, means the daughter cell will be start dividing. Okay, then the daughter cell will be start dividing. So as we know, like we have taken the example of epitone 3. So mitosis means the daughter cell will be start dividing. What will happen? Daughter cell will be start dividing, and those daughter cell containing the plasma 3, as we have taken the epitone 3. So as we know that the epitone have, every epitone have the plasma cell. So epitone 3 will be always having the plasma cell 3. Okay, so here we have the plasma cell 3, and we know that plasma cell, what is plasma cell? Plasma cell will make the antibodies. So here the antibodies that are making single by the mitosis by the daughter cell, that antibodies are known as polyclonal antibodies. What those are known as? Those are known as polyclonal antibodies. Okay, this was the concept of the polyclonal antibodies. We have taken the example of epitone 3. Now we can also take the for like all the epitone. So all the epitone 1, epitone 3 and epitone 2 will be making the will be dividing mitotically, and they will be like the daughter cell will be forming, and every daughter cell then will make the antibodies for the plasma cell 3, and that antibody are known as what? Their antibodies. So those antibodies are known as monoclonal antibodies. Okay. Why, like the question arises over here that, like what's the purpose of the monoclonal antibodies? Okay, what's the purpose over here? So like we use the anti monoclonal antibodies artificially, because in our body the process occurs very slow. So that is why we are applying the antibodies from out, like artificially. Why artificially? Because in our body, as we know, that the process occurs so late. So that is why the antibodies, means the anti-polyclonal antibodies we are applying, so that the antigen should die fast or rapidly, and the poison of that antigen should not spread in the body. Okay, rapid I'm sorry for that. Rapidly. Rapidly. Okay. So like sometime we are making these the polyclonal antibodies and antibodies artificially. So like the concept and these antibodies we are making by what? We are making this by genetic engineering. Okay. Gene genetic Genetic engineering is a process by which we are making the antibodies and we are like using for the cloning purpose. Engineering. Okay, like used for the genetic engineering. Okay, so genetic engineering the process we are like making it by artificially, and that is also known as hybridoma technique. What this is known as? This is also known as hybrid hybrid hybridoma doma technique, or also known as cell culture tech. Okay, hybridoma technique. And if I tell you that who introduced this hybridoma technique and genetic engineer who made this, so talking about the discoveries of this, so it was introduced so in 1975. In 1975, this technique was introduced by George Kohler. This was introduced by who? The G E O R George Kohler, and another scientist that was named as Kohler, and another scientist that is named as G Milestone. G Milestone. Okay, then in like after some time another scientist joined them, and he is named as Niles K. Niles, and they also won the Nobel Prize. Niles K. Then they introduced this technique, but in 2020 2018, there is a scientist who is J Pallison. J Pallison. Okay, J Pallison, and another who is J Honyo. J Honyo. They did the experiment on the cancer cell, like they applied the monoclonal and polyclonal antibodies and they got succeed. Okay, they applied the monoclonal and the antibodies in the living cell of the cancer living cell to treat the cancer, and they succeed and also got the Nobel Prize. Okay, so these were the scientists who work in the field of monoclonal production of the monoclonal antibodies and the polyclonal antibodies.